Hey everyone, Mrs. Ragstad here. This is a video for Chapter 8 that will explain how to do the pre-lab for the volume and density lab. And basically, in this video, I'm only going to talk about the volume portion. And we are going to measure a number of metal objects. We're going to measure their volumes in two different ways and compare them. And so the first way involves simply measuring the dimensions. And we're going to use an instrument called a digital caliper. It looks like this. And can slide over like so. And it's basically like a ruler, but it measures small lengths or widths or heights or distances very accurately. So I have a couple of types of digital calipers. Let's see, this one might be backwards. We're going to be measuring in millimeters. Right now I have this set at inches. So there's a button here that says millimeter/inch/fraction. And I want to make sure that that is set in millimeters. And then the next thing I want to do is make sure that when these, let's see if I can put this over here, these claws right here are completely closed all the way. I want to make sure that my reading is 0. So I'm going to press the 0 button. Okay, make sure it's not negative, not anything like that. So when it says 0.00, then I'm ready to measure. Okay, now let me introduce you to some of the pieces that we're going to measure. I have two cylinders, otherwise known as rods. So this is the aluminum cylinder. You can see it's got a circle on the end. And then we also have the brass rod, also a cylinder. It's much bigger, and it just looks, you can see the color difference, okay? So remember the equation for the volume of a cylinder is pi times the radius squared times the height. And pi times the radius squared, that just comes from the area of the circle. And that's the circle right there. So I'm going to put that right up close. There's our circle. And then the height is going this way. Even if I have my cylinder going sideways, it's still the height. This distance right here. So let me show you how you're going to measure those lengths. So again, I have to make sure this is zeroed. So the height, I'm going to take my caliper and I'm going to make it long enough, and then I'm going to close it in. So it's just snug, you don't want to break it. And this is measuring about 89.89 millimeters. See how accurate that is, how precise that is? Okay, so that's my height. I do want to change my millimeters into centimeters. So in your notebook, you're going to have one column where you're going to write down all the metal pieces, all their measurements in millimeters that you get from the digital caliper, and then all the measurements in centimeters. And if you'll remember from the King Henry died by drinking chocolate milk procedure, we can just move the decimal point one place over to go from millimeters to centimeters. Okay, so if this measured about 90 millimeters, it's 9 centimeters because I'm moving the decimal point over by 1. Okay, now let's talk about the other dimension we have to measure. So if you look again at the circle, we need the radius to find the area of this circle. However, I don't know where the center of this circle is. I mean, it's kind of small. I'm going to put this right up to the camera. There's no dot there telling me where the radius is, where the center is, because remember, for the radius, we have to measure from the center out to the edge. So because I don't have that information, I'm going to measure the diameter instead. The diameter is much easier to remember, or to measure actually, to measure accurately. And to do that, I'm going to take my digital caliper and just go like this. Okay, because that's the distance all the way across the circle. And once I have the diameter, I just divide it by 2, and that gets me the radius. So there's going to be some calculations involved. You're going to have to do some math. Okay, same story for this cylinder, it's just smaller. So again, brass rod, aluminum rod. Now there's some other metal pieces that you're going to need. This is the carbon steel bar, and you'll notice it's a square on the end, and then it has a height. You do still need to measure each dimension separately. So for a prism like this, we measure length times width times height, and that gives us the volume. So I'm going to get height this way, I'm going to turn this over, I'm going to get it this way, and also this way. And I'm going to measure each of those in millimeters from my digital caliper and then convert it to centimeters, and then multiply all three together to find the volume in centimeters cubed. So that's the carbon steel bar. I also have this aluminum flat bar. So you can see it's pretty flat, but it's not two-dimensional, it's three-dimensional still. Okay, so you're going to be measuring, again, length times width times height. Okay, and then last but not least, I don't have one with me right now, but I will find it by the time you do your lab. We have the L shape. And the L shape is basically like two of these flat bars fused together to make an L like that. And so the basic idea for this is you're going to need to make an imaginary cut. You're not going to really cut it. And then measure each flat bar separately and then add them together. Okay, so it'll be a very similar procedure, but I'm going to let you wrestle with where you're measuring for yourself a little bit. So it's going to be a process of adding the two parts together, adding the two prisms together. Okay, now the second way that we're going to measure the volume is called the displacement method. And for that, we're going to take a graduated cylinder and you're going to fill it with water about halfway. The exact amount doesn't matter so much as long as it's enough to cover your piece, because after you put in the water and then measure it very accurately in milliliters, you're going to place your piece in. Okay, so the amount of water has to completely cover your metal piece. If it doesn't completely cover it, it's not enough. If it covers it so much that it overflows or it surpasses the 100 milliliter mark, then that was too much. So you're going to have to adjust your amount of water that you add to that. You may use tap water for this because it doesn't matter about the contamination. It only matters that we're measuring volume. And the cool thing about the displacement method is that you don't need a regular shape, because we have formulas in math for finding the volume of prisms and stuff, but what if it was like a little gummy bear or something? Like, we don't have any formula in math to measure the volume of a gummy bear. It's too complex. There's too many curves, and there's feet and head and ears and all that kind of thing. But the displacement method doesn't care about the shape, because whatever you place into this water, the water is going to surround it, and it's going to rise to the level of whatever the volume is that you put in there. So to find the volume by displacement, step one, we fill it up to about halfway, as long as it's enough, say 60 milliliters. And then you're going to write that number down very accurately. So it might be 61.2 milliliters. Then we're going to carefully slide in our object. We don't want anything to spill or splash. And then we're going to write down the second measurement of how much the water rises to. And then you're going to subtract it. And the subtracted value is the volume of just the object that you put in there. Okay, now when you take it out, you're going to hold it over the sink because your hand will get wet. You're going to place your hand on the top and you're going to hold it over so you catch the object, you don't let it fall. Your hand will get wet, there will be water all over it, but you're over the sink, so it's okay. You catch the object, and then there's paper towels so you can dry your hand off. All right, also one more thing to note, the L shapes. Really test the integrity of these. So there's some graduated cylinders that are a little wider than others, and I want you to test and make sure that it actually fits before you place it in, because I've had people get their L shape stuck up here and then we have to try to get it out and it's not pretty. So test it before you put the L shape in. All the other shapes should fit just fine. All right, so that's it for the procedure on the lab. I will make another video later that shows you how to analyze your data and how to plot it in Google Sheets, how to do formulas and all that kind of thing. Alrighty, so go ahead, have a great day.